Welcome back, chemistry fans. I'm going to provide the solution to the warm-up for today, day 27. All right, here we go. Let's jump into it. I'm going to share with you my screen, and it asks for what are valence electrons? Valence electrons are the electrons that are on the outer, not outer, the outer, that's outer, no, it's outer, the outer energy levels. Last ring. So we count those, of course, by the columns on the periodic table. So that's what question number 2 is asking. How many valence electrons are there for antimony, Sb? Well, let's go find antimony. Antimony on our periodic table. Here we have a periodic table already at the top. I have my charges listed on here, but I am not asking for that. I am asking for what is the number of valence electrons. So first off, we got to find Sb. Sb is down here, and it is, if we are counting valence electrons, all of them in the first have 1, all of them in the second have 2. We skip over here to 3, 4, and antimony has 5 valence electrons. So going back to the question at stake here, how many valence electrons does antimony have? It has 5. What is the charge of a proton? It is positive. What is the charge of an electron? What is the octet rule? It says that all atoms want 8 valence electrons. So if you don't have 8, you're going to steal them. You're going to give them away and lose an energy level so that you have the stable octet. How does Sb achieve a stable octet? So let's go back and look at where it is. Antimony has 2 choices. It can either lose the 5 valence electrons that we have, or what it could do is it could move. Let me get a color that you can actually see. Let me try yellow, maybe. I don't know. Yellow you'll be able to see. You will there, but you won't be able to see it on the next one. Let me just go with black. So if we take antimony and it moves 1, 2, 3 places, that means it could gain 3 electrons, or it could lose 5 electrons. It is always going to do whichever is easier. Now, second to this is the fact that antimony is going to be a metal, and so it tends to want to lose its electrons. But in this case, it's one of these. It could go either way, but the shorter path is to gain 5 electrons. But again, now here's the overriding story. Antimony happens to fall over here on the right side. So it's actually going to lose its 5 electrons. And I know that that's confusing. It's a hard concept to figure out. But what we've got to remind ourselves is that antimony is to the left of the staircase, meaning it is a metal, meaning it is going to always lose. So this is one of the rare instances where we don't have it following the predicted path it should. So it is going to lose its 5 valence electrons. So what's it going to do? It's going to lose 5. What is the charge of Sb? Well, then because it did that, it's going to end up with a charge of +5 because it lost all of these 5 negatives. So that means it has now more protons than it does electrons. Which element do you think that Sb would like to bond with? Well, it's going to have to find someone out there who needs 5 valence electrons. Well, that's going to be a rare one. So let's go and see if there's anyone who would be willing to steal 5 electrons. The only person that I can see that would be willing to steal 5 electrons is going to be boron up here. And I know that it's in a +3 column, but that's if it's a metal. Because it is a non-metal, it's actually going to want to try and steal 5 electrons. So antimony would find very strong comfort in bonding itself with boron because boron needs 5 electrons to get a stable octet. Antimony is willing to give 5 electrons. Now, if we were to do something a little bit more simple, say we had aluminum right below it, aluminum would want to give 3 electrons, but nitrogen would want to gain 3 electrons. All right. Well, this was a challenging one for you. Hopefully you are finding a little bit of information that will be useful as we move forward. Thank you so much for your time. I will talk with you again soon. Farewell.